So on the back of 7.9, we start yet another new idea. Another new idea is how can I find how much volume a gas fills up, knowing things about its pressure, its temperature, things I knew about before, but now how many moles of gas are in there? Yes, our old friend moles are back. All the things you know about moles apply. So we're going to do moles. And so the new formula for ideal gas laws are PV over T, but I'm moving the T to the other side because I don't want it on the bottom. And then I've got N, R, and T. Now remember, T has to be in degrees Kelvin. It is our old friend. N is number of moles. Aha! And then R is interesting because it's right down here. But why is there two of them? We use one when we use atmospheres, the other when we do kilopascals. Okay, so if I use kilopascals, I use one. When I use atmospheres, I use the other. All right, so here we go. Example problems. How do you do this? So again, same PV over T, but again, if I double, as you hopefully did in the previous problem, when you double the number of moles, that means you're doubling the number of atoms or molecules. You double the number of atoms or molecules, gas is going to be twice as big. If it's done, everything else is the same. All right, here we go. 2 moles of a gas at 297 degrees Kelvin at 1.3 atmospheres. How many liters, somebody said before, it should be liters, how many liters of this gas would fill up? Okay, so here we go. We go PV equals nRT. The pressure, under pressure is 1.30 atmospheres. The volume, I don't know, but it asks how many liters, so volume will work for us. I've got N, number of moles, I got 2.0. R, okay, which one do I use? So I notice my pressure is written in atmospheres. So this is the atmospheres one. So I'm going to use 0.0821. And then my temperature has got to be in degrees Kelvin. It is. It says 297 degrees Kelvin. So I can go ahead and just plunk it right in. And the rest is just doing some math on it. Doing some math on it, I got 2 times 0.0821 times 297 divided by 1.3. Oh, I did that too fast. So you got 1.30 V equals 48, nope, 37, where do you get 48 from? 37.51338 divided by 1.3 both sides. And I get my volumes equal to 37.5. Oh, this is only good at 2 digits over here. So this is only good at 2 digits, so I'm going to say 38. And it's going to be measured in liters. How do I know it's liters? Because these constants tell me what I can measure things in. The L stands for liters, so this is going to be liters. So that's my correct answer for that one. Okay, let's try the next problem. Shouldn't be that bad. Looks like that was pretty good. PV equals nRT. How do I know you're doing PV equals nRT? Because it uses the word moles. And if I have moles of a gas, I can convert it to pressure and volume and temperature using this formula. Okay, so the pressure doesn't say. Volume, 22.4 liters equals N, 3 moles. R, now here's interesting. It doesn't give me a pressure. Well, it doesn't matter. You pick either one, you can use it now. I'm going to go ahead and do 8.31. And then my temperature is going to be 273. Slap that in my calculator, I get 3 times 8.31 times 273. And I get 6805.89 equals 22.4 P. Divide by 22.4, both sides. And I get my pressure is sitting at 303 kPa. How do I know it's kPa? Because since I use this one, it'd be kPa. If you use the other one, you would get atmospheres. You'd say, and by the way, you get about 3, so it'd be 3.00 atmospheres or something like that. Okay, kPa right there. All right, the rest of this should be doable. So have at. It should be a piece of cake for you mostly. Finish that sucker off. And if you're having trouble, come on in.